Hi everyone, my name is Nilis Dinis, and I'm the product manager for Lunatic and Stunner at Enchain Labs. I will be your moderator, and thank you all for joining us today. We will have a Q&A session at the end of the demo. To ask questions, all you have to do is click on Q&A in the Zoom navigation bar at the top or bottom of your screen and type in your question. We will get to as many of them as we can. And now I'd like to introduce Kevin Lance, our marketing manager for the analytics portfolio. Today, Kevin will show you all about Stunner's simple solutions for one-step quantification and sizing of any nanoparticle by walking us through a quick demo of the instrument. Now I'll hand it over to Kevin. Hi.
Thanks, Nilis. How's the weather over there in Belgium?
We're finally getting some sun this summer, so all good.
Sounds like summertime almost. All right, so let's get started with an introduction to Stunner and how it helps solve the problems of nanoparticle quantification and sizing. Stunner performs UV Vis and DLS measurements on a single 2 microliter sample for any nanoparticle. Each measurement is done in a Stunner plate where microfluidic circuits have UV Vis path lengths of less than 1 millimeter. This is critical because normal UV Vis measurements on nanoparticle samples, especially like LNPs, can be impossible due to turbidity or cloudiness blocking the transmission of light. Stunner's microfluidic circuits also make incredibly precise measurements because the UV Vis path length is fixed. There's plastic on top and bottom of the measurement that are not moving. So if you combine those two factors, short path lengths and precise measurements, with Stunner's advanced Unmix deconvolution algorithms, and that's how it's now possible to quantify nanoparticles on Stunner. We'll take a closer look at those algorithms when we check out our results later. Stunner is also a high-throughput DLS solution capable of reading sizing information from the same 2 microliter sample volume for up to 96 samples at a time. It gives you way more walkaway time than with a one-at-a-time DLS system. For the demo today, I have 2 samples to take a look at, some RNA LNPs and a more complex sample of RNA LNPs and lysozyme LNPs meant to simulate a protein conjugated RNA LNP. We'll use 2 different applications to quantify each while getting sizing information from DLS at the same time. Okay, so let's go load up those samples and we'll take a closer look at the Stunner plate. Here we're looking at the Stunner plate, which, as you can see, follows the normal 8x12 format for a 96-well plate. So each one of these individual circles here is an individual input well, where we'll be loading in our 2 microliters of sample. Let's see if I can get that to show up. There it is. 2 microliters of sample and then reading that on Stunner. So to load it, it's a pretty simple process where I'm just starting with the native RNA LNP, and I've not done any kind of disruption workflow or dye-based workflow or anything to this sample. So all I'm doing is adding it to our well, and it gets quickly wicked in there and stored safely away from evaporation since it's residing within the microfluidic circuit. If you're paying close attention, you'll notice that I'm doing reverse pipetting. That helps eliminate the possibility of getting any error bubbles. Okay, so that's 1 triplicate sample of my RNA LNPs, the simple mixture. Next, I'm loading in my more complex mixture, which this is lysozyme-loaded LNPs and RNA LNPs as well. And 3. Okay, so that's 2 triplicate samples of LNPs. And the last step, and the only other thing that I need to run my plate, is going to be a water blank. This will go really quick because I just need 1 water blank per sample. Okay, and that's it. So compared to doing some more complex dye-based setup, a pretty quick setup to run a quantification experiment on LNPs. So we're all set with our samples now. Let's take this back over to Stunner and set up our run. Okay, so to set up the run on Stunner, first we're going to dig into the software, which I'll go ahead and do a screen share through Zoom so you can follow right along with me. So here we're checking out the client Stunner software, which is going to be what's running the experiment. So I'll dive into the gene therapy applications here and just go and select the RNA LNP app. So this is one of 3 out-of-the-box applications that's set up really well to look for, RNA and RNA LNPs, protein and protein LNPs, or DNA LNPs. So we'll be reading the RNA LNPs first. So I'll start with that application in our stunner plate and just name the file really quickly, LNP live demo file. And I'll use the default settings for DLS, which for stunner is a 4 by 5 second read. Okay, so now I can go through and assign where all my samples and blanks are manually. It's quite quick process, just clicking and dragging through our interface. But to make things even faster, since we're doing this on live TV, I'll import everything from a pre-written Excel file that is simple as clicking those couple of buttons. And so now what Stunner already knows is where my samples are, which is those 2 samples in triplicate, my 2 blanks. And it even knows which samples to group together. So in red is my RNA LNP samples, all grouped together with triplicate samples and a blank. And in orange are my custom LNP mix. Okay, I'll hit next. And what I'm looking for in my RNA LNPs is an mRNA payload. So that looks great. And I'm in a water buffer. This is a review screen just to make sure that everything looks like I expect. And it looks wonderful. And one last review screen. And we are ready to load up the plate onto Stunner. So watch the video, and I'll just simply drop in the plate nice and easily. Okay, so all we're doing now is hitting start, and Stunner's going to go ahead and read those 8 samples. It'll take about 6 minutes to get through of all of those. So what I'm going to do instead is, instead of sitting here and watching Stunner, I'm going to show you a little bit of data explaining what's going to go on with the deconvolution algorithms. Okay, so here we're looking at just a PowerPoint slide. And on the left, what I'm showing you is the UV-Vis signal for a set of empty LNPs. Now, this is actually light scattering and not absorbance, but either way, the signal's there and it's kind of getting in the way and not really useful. So if I add RNA LNPs, I get the signal on the right, and I now have a sort of a slight suggestion of a shoulder where my RNA is now absorbing, kind of additive to my turbidity signal, which is coming from the LNP structure itself. So what would be ideal is if I could get rid of that turbidity signal and analyze just the RNA signal. Now, if I was trying to do this manually, what I might think to do is smash these 2 curves together and try to subtract the empty from the full and get left over with the RNA. But the problem with that is this turbidity curve is going to be dependent on composition, size, and concentration of LNPs. So it's going to be almost impossible to get an apples to apples comparison where I can successfully blank out or subtract my empty signal. So that's why Stunner has a better way, just doing everything through its analysis algorithms, which don't require any kind of extra work. So what we're doing here is taking the raw data and we're deconvoluting it to look at its individual components. So again, this top curve, this dark gray curve, and this black curve is the same data you saw on the previous slide. But we're breaking down that total spectra into first turbidity, which is that light gray, nice smooth curve. And then once we've subtracted out the turbidity, we can look at the remaining components in our sample, which is going to be RNA that we really care about to get a total RNA concentration, in this case, 81.6 microgram per mil. And then some extra contribution from lipid signals and buffer signals that Stunner's looking for from its sort of library of analytes. All right, so that's a quick overview of how the algorithms are going to be looking for answers with Stunner. I think that gives us a couple more minutes before Stunner's finished with its reads. So while that happens, we can maybe take a couple questions. So hey, Nellis, what are some of the frequently asked questions that you hear about Stunner?
Okay, yeah, I would say the first one would be, can you actually run like only one sample at a time on Stunner, and how long would that take?
Yes, if you want to just run one sample, it takes 45 seconds to read each well. And so typically you'll do a water blank and an LNP sample if that's all you're interested in, and get those answers pretty quick, in about a minute and a half. If you want to run a full plate on Stunner, that takes about 45 minutes to get all of that Vis and DLS data.
Okay. Would you need an empty nanoparticle to blank your sample, or a way to correct for turbidity?
Nope. All that turbidity correction is done by fitting a library of turbidity curves in Stunner software to the results that you're getting from the UV-Vis. So that's why we don't need those those empty LNP samples, because Stunner already know what turbidity looks like and finds the best fit for your read every single time.
Okay, and if people would have their own special proprietary vector, how would they do a measurement with Stunner?
So good question. And that really opens up the floor to any kind of custom nanoparticle. So today, what we're looking at is an RNA lysozyme nanoparticle. But what you can do with Stunner is use those 3 out-of-the-box applications, RNA, DNA, and protein. Or you can build a custom nanoparticle, and I'll walk through the software and how to do that. That can be composed of whatever kind of payload you can teach Stunner about, and whatever kind of particle composition you know about your nanoparticle.
Okay, something else that's frequently asked is can people automate Stunner?
Yes, yeah, it's very easy to hook Stunner up to a lot of the automation platforms out there and get through even higher throughput with the help of an automation solution.
Okay, and for specifically for LNP samples, let's keep that one for the Q&A. I see the instrument is ready.
Yeah, if it doesn't come up in the Q&A, then yeah, please hop in and ask. Okay, so the plate popped out, and so we're all set with that. And now we can go check out the results in the analysis software. Okay, so again, I will fire up the screen share here, and we'll take a look through, let's see, the analysis. So starting with the overview, what we have here is our RNA LNP samples, and what we're looking at is the UV-Vis signal, and I'll explain what each of these curves are when we look at each sample. But below that, we have one number explaining what the total concentration is. So you can see that these values are all about 62 microgram per mil for RNA. If we want to check out a quick overview for DLS, it's easy enough to look at intensity or mass distributions and get a really quick idea of Z average diameter as well. So let's drill down and check out UV-Vis absorbance a bit more. So now I'm looking at the first of these 3 RNA samples. And just to kind of show you what I showed you on the PowerPoint slides, I'm going to kind of back out and look at the raw data for what Stunner actually saw using UV-Vis on these samples. What you can see is that really high contribution from turbidity, and that's that sort of predominant curve shape going across that whole spectrum. So if we overlay all 3 of those samples, you can get an idea of Stunner's precision as well, because those curves are lying right on top of each other. So that's nice, but again, we're stuck at that place where we really want to get rid of that turbidity signal and understand the underlying contribution of the payload, which is the RNA we really care about. So if I go back to the processed signal, what we're looking at here is the turbidity curve in gray, and that's been subtracted out from that raw data, and the remaining absorbance is here in black. Against that black spectra, what we're fitting is RNA in green, and then we also have the contribution from buffer or particle components like cholesterol present in blue, and yellow is any kind of remaining signal that's not fit by the green and blue curves. I can quickly overlay these signals as well, and you can see again the precision in the process signal. And if we check out the results, it's about 61.5 microgram per mil, 62.5, 62.9. So all right around that 62 microgram per mil value. Checking out DLS, it's pretty quick and nice and easy, going to about 104, 105 nanometers in diameter, which is pretty much what we expect with this sample. Okay, so that's the RNA LNPs running just the out-of-the-box canned RNA LNP application. But we also know that we have this custom LNP sample. So how do we deal with that? Well, to explain it a bit more, I'm going to dive into how you set up a custom LNP on Stunner. So you go to the Analytes menu, and here is a lysozyme LNP with RNA that I've built. There's a lot of customizable parameters here, but what I want to focus on is one thing, which is the composition of this LNP. Now, the way I've built this LNP is by selecting lysozyme as the payload. So that means that Stunner is looking for protein as that green curve. So when I run these samples, when I analyze them, what we're going to see is a milligram per mil concentration of protein. In my particle, what I've put is a library of LNP lipids that's already in the Stunner library, and an mRNA sample, mRNA analyte that I know is in my sample. So kind of to sum up, it's telling Stunner to look for lysozyme as a protein payload and lipids and mRNA as other signal that's present. If I wanted to flip things around and put mRNA as the payload I'm most interested in, and lysozyme as part of the background particle signal, that's really easy to do. Okay, so that's the analyte that I'll be looking for. Now, if I want to have Stunner's software go check that out, I'll change applications and look at custom nanoparticles, which is going to allow me to recalculate the same signal I've already ran with a new analyte in mind. So I can go select that lysozyme and RNA LNP sample, and again, water buffer. And Stunner is going to just take a couple of seconds to rerun its deconvolution algorithms through Unmix to understand what the underlying signal is there. So now I'm looking at this custom LNP signal, and I could check out the raw data. It looks to the eye very similar to the RNA LNPs. So here we'll just do an overlay of the deconvoluted data and still get an idea of the great precision, that Stunner gives you on these custom LNPs. If we look at each signal individually, we can see where all the different contributions of the LNP components have been deconvoluted out, where we have the, again, gray line for turbidity, the black line for remaining total spectrum. Now green is the payload that's lysozyme. So with this particular spectra, I'm getting about 0.34 mg per mil protein concentration. And then the RNA and lipid and buffer components are still in this blue curve down here. And you can see that you get the same idea for all of these different LNPs. So if we want to check out DLS, same kind of data that we saw for the RNA LNP as well. Okay, so that's a quick overview of the two different applications, RNA LNPs and custom LNPs that we can use on Stunner to analyze our nanoparticles. Okay, with that, I think it's time to kick it over to Nellis, and let's see what kind of Q&A has popped in.
Yes, thank you for that great demo. I actually just did the quick math on those RNA LNP samples, and the average on RNA was about 62.34 nanograms per microliter, with a precision in percent CV of 0.93. And the DLS, the average was about 104 with a percent CV of 0.83%. So overall, very nice
precision.
data. Kevin showed us how fast and easy Stunner is to do payload, quant, and particle sizing on just 2 microliter of sample, not only with the specific applications like the RNA LNP, but basically on any nanoparticle with our custom nanoparticle app. So we have already some great questions that have been submitted. You can, of course, still ask a question by entering it in the Q&A section of your Zoom navigation bar. Okay, let's kick this off. Can you run samples containing ethanol on Stunner?
Yes, Stunner can run ethanol containing samples up to about 20% ethanol, which makes a lot of sense if you have an LNP process where you have some ethanol coming out right at the end too. So you can run a quick read and see what the concentration is up to that 20% level.
Okay. What is the dynamic range for quantifying particles?
So this will be a little bit sample dependent. On the lower end, it's going to be around 5 microgram per mil as a rule of thumb. And on the upper end, it'll be somewhere in the neighborhood of 150 to 200 microgram per milliliter. And I've seen upper ends that go almost to 250 microgram per milliliter. The reason why that's sample dependent is because the UV-Vis parameters depend both on RNA and turbidity. So the OD maxima, for example, on Stunner is 275 OD. So if the turbidity and RNA signal combined are less than 275 OD, you're good. If they're greater than 275 OD, that's above the maximum limit. So it just depends on what the mix of turbidity and RNA is for any given sample.
Okay. Someone is asking if you can calculate encapsulation efficiency for RNA LNPs with Stunner.
Not directly. So most customers are using Stunner to make quick reads of total concentration of RNA. or quick reads of DLS, especially in high throughput. There's a few workflows that Stunner can help get to encapsulation efficiency faster and with fewer standards and dyes. But by and large, Stunner is the really quick answer for total RNA.
Indeed. Can you use Stunner for other UV-Vis applications?
Absolutely. So today we focused on Stunner specifically for nanoparticles, which I love it. It's a pretty cool field to be in because it's exploding right now. But AAV is where Stunner also excels because it can give you results on things like capsid titer, genome titer, size and aggregation. Or if you're, say, preparing your reagents to make a nanoparticle and you want to get a quantification of some of your RNA or quantification of a protein component for some other process, Stunner is an excellent way to quantify and check for aggregation for those kinds of samples. So you get a really good, accurate, and precise reads for both nucleic acid and protein quant.
Someone wants a bit clarification on what you mean with MDLMP. Does that mean just without messenger RNA?
Yes, so it's not something that every LNP platform can do, but in this case, with that particular data set, which was using Genvoy ILM from Precision Nanosystems, you are able to make empty LNPs and kind of show what that light scattering curve looks like. And yes, in this case, it was without mRNA payload, so just the lipid mix.
Okay. Are plates reusable if not all wells are used?
Yes, so once you use a single well, that's it. The sample's kind of left in that well. And so you can't use that single well anymore, but you can use all the wells in a plate and just kind of be efficient. So reread a plate, if you're doing one sample at a time, you can reread a plate 96 times, that kind of thing.
Okay, do you need any sample prep or lysing the nanoparticles before detection?
No, actually. So what I kind of showed in my loading was taking the samples right out of my LNP mix. And that could have been a sample coming right off of the production line, or it could have come right off of a buffer exchange system. And it's just ready to go as is. It's actually one of the really cool problems that Stunner helps to solve. As I've had customers tell me about an LNP sample that was aggregated. But when they ran it on, a one at a time DLS system, they had to dilute the sample 1,000-fold to get to the volumes that they needed. Well, that aggregated sample, once it got diluted 1,000-fold, was a different sample that didn't show the same aggregation problems. Or if they were quantifying it by like a ribogreen assay, well, that's a 9-step workflow with disruption and standards and surfactants. And so that sample's also not the same sample you started with. But if you take that problem sample and just run it on a Stunner, you don't have to follow any workflow. You're just getting direct results on concentration and sizing on the sample that you're getting off of your production
line. Someone is asking about the recalculation you just did. So don't they have to rerun the samples if you need to check a different payload for the same samples?
No, if you're running several different LNP samples and really checking out different things, since a lot of that analysis is just happening with Stunner's deconvolution algorithms, it's the same underlying UV-Vis data and just telling Stunner to analyze it a different way, keeping some in mind that, for example, the payload might be protein this time instead of RNA. So there's no need to rerun. The data's there. Stunner just needs to look at it with a kind of a different starting point in mind.
I think something that nicely fits in that same story is, can an individual well be reread?
An individual well be reread? No, I think it's the read you get is what Stunner has. Yeah.
Indeed. Is the UV-Vis in Stunner the same as UV-Vis in the Uncle? I think here they mean DLS in Stunner the same as DLS in Uncle.
So the DLS in Stunner, it's similar. It has the same laser wavelength. We're detecting at a different angle than the DLS in Uncle, but some of the hardware is similar. Yes, and then UV-Vis on Stunner is similar to the UV-Vis on Lunatic. So you have kind of the blending of two platforms to get you these great answers on concentration and size in that small volume.
Okay, a bit more technical, and then the next question fits that is, in case you would know, the angle between laser and detector in Stunner.
Oh, this is a good question. Nellis, you're stumping me. Is it, yeah, you take this one. I always,
Yeah,
always blank.
it's around 142, but that will be
142.
a little bit more or less depending on the
So
instrument.
for comparison, the angle on Uncle is 90 degrees. So 142 versus 90-degree detection.
Yes. Let's see. In the custom setup, so with the custom nanoparticle, what if you do not really know what your payload or your particle is, or you don't, yeah, you just want to check it out? How much information does Stunner need to actually run it?
It needs some kind of starting point. So one thing you can do is run your payload on its own and actually teach Stunner. So it's something we didn't talk about today because we were using a pretty simple lysozyme sample. But if you had something more complicated, and we have an example with doxorubicin that we show a lot, you can teach Stunner what that UV-Vis absorbance behavior is. Run a dilution series on Stunner's UV-Vis, and Stunner can then take that in and build the new analyte. So it's the kind of thing where you can use how smart Stunner is to get really good results out the other end of it by teaching it about your payload.
Yes, I think the next question fits that a bit. When you build your own particle, do you need to input the information of protein, RNA, and lipids such as EC value, molecular weight, spectra, or how do you input things like that?
So for the payload, it's going to be helpful to know the extinction coefficient and things like that, so you can get an actual concentration out at the end of it. And then for particle, I believe you don't need that type of information. Nellis, do you want to add any detail to that?
No, I think that's the main thing. We have preset specs for particles. Of course, if you have something custom, of course, you need to tell Stunner a minimum of information, definitely if it's absorbing, but that's all possible within the software. I'm seeing something else. If Stunner has any temperature control?
No, Stunner doesn't have temperature control. If you're interested in looking at thermal stability, then Uncle is the product that can definitely help you with that.
Okay, and they keep on
I will say
coming.
Stunner does read the temperature though. So because temperature is a part of DLS, you do need to know what the temperature is.
Yeah, that's exactly right. It's a bit specific on numbers. So what about sample viscosity? Do we know what the max acceptable is? And if there are any issues, it's a double question, with polysorbate concentration in the buffer. If you want, I can
Yeah,
step
so
in.
yeah, so with viscosity, I believe the upper limit is 40 centipoise. It's not something that we've hit with our LNP samples. It's more typically hundreds of milligram per mil protein samples where there's issues. With polysorbate, I've not personally run polysorbate on Stunner yet. Nellis, have you seen that kind of data? It's something we have in lab and can check out.
Yeah, I've seen a bit of data. I think if my memory serves me right, for like tween 80, it would be about 10% as a maximum limit. And I think tween 20 would be around 2% as a maximum limit, but it will really depend on the polysorbate and your sample itself.
Yeah, and if UV-Vis absorbance is or scattering is a concern there, that's the kind of thing where you could teach Stunner about that absorbance characteristic and put it into that particle component for a custom LNP or custom nanoparticle.
Okay, I'm looking into this. One question is if there's any official FDA regulation. I would say no on that one. We're always looking in it.
Yeah, I will say our instruments
FDA
are
approved.
research use only. Yeah, instruments are research use only. They do translate downstream. They have a lot of tools to make that easy to get into those more GMP type labs that might be more concerned about FDA requirements. So for example, we have 21 CFR Part 11 software tools that allow you to really lock down audit trails and traceability and things like that. We also have IQ/OQ PV services that allow you to confirm performance and do things like verify stunner is performing according to the USP or European Pharmacopoeia requirements for a UV-Vis instrument. So kind of two things that are pretty excellent, making sure that stunner matches what's expected in a regulated environment.
Okay, I think we have time for one more. You quickly touched based on it in the very beginning, but what is the lowest concentration limit for analysis?
The lowest concentration limit for analysis is 0.03 OD, which translates, if you're looking at a pure DNA sample, that's going to be 1.5 nanogram per microliter. If your protein sample, that'll be 0.03 mg per mil. And for an LNP type of sample, it depends again on how much turbidity is part of your signal, but rule of thumb, 5 microgram per mil RNA.
Okay, that's all we have. So thanks for this informative walkthrough of the stunner and answering all those questions, Gavin. And I also want to thank everyone that joined us live today. If you would like to have a deeper conversation with our team, please don't hesitate to get in touch with us through either our website or just by emailing info@enchainlabs.com. Our team would, of course, love to connect with you. Thank you again for attending us live today, and I hope you all have a great rest of your day.